Hey there everyone, Mr. Dickin here, and this is going to be our last and final video for the content of Unit 2. So hey, we made it this far, alright. In this video we're going to be talking about piecewise functions. Piecewise functions are when we have several different portions of different graphs kind of graphed together on the same coordinate system. Now with these piecewise functions, for some of you it's going to click right away. And for some of you, it's going to take a while before it finally makes sense. I remember when I first learned this, when I was in high school, it did not make sense to me at all until probably like 2 weeks after I'd learned it. So if you need to pause this and rewind and pause and rewind and pause and rewind, please feel free to do so. And we'll do our best to make this make sense. So here we go. All right, piecewise functions can be defined by two or more, so multiple functions, that are graphed over a specified domain. So where it says specified domain, keep in mind, that just means over specific x values. All right, so we're going to have different graphs or different functions being graphed, but only if the x values fall within a certain range. So here is what an example of a piecewise function might look like. It's scary, I know. So here we have, it looks like 3 different function rules to follow when our x values fall into certain ranges. So these 3 pieces, they're all going to take place on one single graph. Okay? Over on the right-hand side, these portions here, these tell me when we're going to be using this function rule depending on the x value. So for instance, this x plus 3 quantity squared, we're only going to be graphing that part when our x values are less than or equal to -2. So -2, -3, -4, so on and so on. Those will all follow this function rule. Then when my x values are between -2 and 0, it's going to be just a constant function of 2. And then over here, when my x value is bigger than 0, so 1, 2, 3, 4, whatever, it's going to be an absolute value function, -x minus 1 plus 1. All right, so here's where I'm going to try my best to kind of sketch one out, just so you guys can kind of see where this is going to go, and then I'll show you what the official graph will look like. So here is my coordinate system. Yay, fancy. Let's see, we don't have to go too terribly far on that. So let's say that's my x-axis. This first graph here, the x plus 3 quantity squared, well, I know that that is going to be a parabola of sorts that got shifted upwards, but I only care about the portion of that graph that's less than 2 for my x values. So it's really only going to be like that part there. So if I were to ballpark it, I don't know, it might look something like that. Who knows? And then we have a constant value of 2 when our x values, so right here, are between -2 and 0, sorry. So that's going to be just a constant value of 2. So that might look something like that. And then lastly, we have an absolute value function, and that takes place when my x values are bigger than 0, so everything to the right of 0 here. And that's an absolute value function with a negative, so it's going to look like an upside down V. But again, we're only going to be focused kind of on this portion here because we only really care about the x values bigger than 0. So if I were to guess what that might look like, and again, this is just kind of ballparking stuff here, I might say something like that, but I don't know. So you'll notice we have each one of these functions represented, but it's only a piece of it, so it's not the entire function itself. So let's see what the official graph looks like. Yeah, that's kind of close. A little off, but whatever. All right, so you'll notice, let me see if I can get some of this stuff out of the way. You'll notice that each one of these functions makes an appearance on our graph for certain ranges. So all of these x values, that's going to be where our functions kind of change from one rule to the other. Okay, so the first one we have that parabola. The second function, which was just that constant of 2, and that's going to take place for my x values between -2 and 0. And then lastly, we have our absolute value function, and that's when things are bigger than 0. Now, another piece you might notice is sometimes when these lines intersect kind of our boundary or our domain restriction, sometimes there's an empty circle or a hollow circle. Sometimes it's a filled-in dot. Well, the way we determine whether it's hollow or filled in is whether or not the symbol has an underline. So my first function is for when x is less than or equal to -2. So this first function will be defined all the way up to and including the x value of -2 here. The second function, you'll notice it does not have this little underline piece, so it does not get filled in here. But it does have it for the 0, so when it approaches x is 0, it will get filled in. Another little rule of thumb, you will never have two filled in circles directly above one another. Because if we did, it would not be a function. Okay. So this was kind of a complex example. Let's start kind of easy when it comes time to evaluate them, and then we'll start to graph as well. So let's get into evaluations. I'm going to go ahead and color code these two. So we have two function rules. We're going to follow the rule x minus 1 if our x value is less than 0, basically any negative number. And then we're going to follow the rule x plus 2 if our function is greater than or equal to, or sorry, if our x value, our input, is greater than or equal to 0. So for all of these values here, I'm going to follow one of these two rules based on my x value, based on the input. Let's see. I'm going to go through and figure out anything that has x is less than 0. So any negatives, I'm going to highlight those in yellow. So this one is going to follow the yellow rule. This one would be the yellow rule. And then anything that has an x value of 0 or bigger will be green. So I'll color code. This would be green. This would be green. All right, so for the first one, f of -3, I'm going to be following that yellow rule. So I'm going to plug in -3 for x, and I would get -3 minus 1. Let's see, -3 minus 1, that's -4. Ooh, that should be -1. Ugh. Sorry about that, folks. So -3 minus 1, which would be -4. Next one right here, f of 0. So I'm following the green rule. I'm going to plug in 0 for x. 0 plus 2, well, that's just 2. Down here, f of 5. Based on this input value, I'm following this function rule. 5 is my x value, so x plus 2, 5 plus 2. That's going to be 7. And then last, we have f of -1. -1 would follow this first function rule, so -1 minus 1 would give me -2. All right, let's see another example just like that one. Here we have 3 different function rules, which means we have 3 different specified domains. Anything less than or equal to -3, between -3 and 1, including the 1, and anything bigger than +1. Just like before, I'm going to go ahead and color code these. By the way, if any of you are fans of using highlighters in math, this is the perfect lesson to do that. All right, so I'm going to go through and highlight anything that has an x value of -3 or smaller. So -3, -4, -5, so on and so on. I'm going to highlight that with yellow. It looks like this is the only one. Here, anything that's bigger than -3 but smaller, less than 1, including 1. So that's basically -2, -1, 0, or 1. So I'm seeing both of these right here. Would follow the green rule. And then anything bigger than 1, well, 4 is clearly bigger than 1, so that'll follow the blue rule. All right, so now we get to evaluate. F of 1, I'm following the green rule. So -x, if x is 1, -1 is, well, that's just -1. F of 4, since 4 is bigger than 1, I'm following this function rule over here. So x squared plus 4, 4 squared plus 4. 4 squared is 16, add 4, I'm getting 20. F of 0, since 0 falls within this range here of the domain, I'm following the function rule -x. X is 0, so -0, still 0. And lastly, f of -3. -3 is less than or equal to -3, so we're following this function rule, 2x plus 1. My x value is -3. 2 times -3 is -6, plus 1 is -5. All right, so that's the evaluations. Now we graph. Bum, bum, bum. All right, so I've got 3 examples here for the graphing. We'll take our time through the first one and second one, and then the last one will kind of go a little bit quicker. And we'll see how we do. All right. So when we graph, it's going to be just like we're graphing our regular functions, only we have to graph each part of its specified domain. So that means we're just going to be focusing on a certain portion of the graph, not the entire function. So I want to graph the following functions. X plus 1 if my x value is less than 0. And then x squared plus 2 if my x values are greater than 0. So what I like to do is kind of imagine there's a boundary line at given x values based on these numbers over here. Well, this value is 0, so I'm going to go ahead and kind of imagine I've got a boundary line when x is 0. So there's like a little boundary. Over on the left-hand side, everything that I graph is going to be following that yellow rule. Over on the right-hand side, everything is always going to be following that green rule. Okay. So now let's get graphing. On the left, we're going to have x plus 1. Well, that's just a linear equation, right? Y equals mx plus b. It's got a slope of 1, y-intercept of 1. So that's not too terribly difficult to graph. I'm going to zoom in to make this easier. So we're going to have a y-intercept of 1. So that's this point right here. And the slope is 1, so I'd go up 1, over 1, up 1, over 1. But if I do that, I'm going to go into the green section. And we really don't care about the stuff over there in the green section. So instead of graphing up 1, over 1, up 1, over 1, I'm going to go back here and do backwards 1, down 1. Okay? So I'm going to graph these points over here. It's still going to create the same line. It's just not going to give us the incorrect portion, if you will. All right. So let me graph that real fast. Now when I get to the actual part of the graph where it intersects that boundary line, I have to figure out is it going to be an empty circle or filled in circle. According to this, there's no underline, so it's going to be an empty circle. There we go. All right, now for the second one, we have x squared plus 2. Well, that's going to be a quadratic, so it's going to be a parabola. It got shifted up 2 units, so my vertex has been shifted up 2. Now we can follow that 1, 3, 5 pattern. All right, so we shifted up 2 units. And then I go up 1 over 1, and then up 3 over 1. I could do the same thing over on this side. But again, since it's a piecewise, I only care about the x values bigger than 0, so I'm going to ignore that section of the graph anyhow. All right, so now when we graph, that should be a little bit more curved, but you get the idea. And we're going to make sure that that's a filled-in circle where it intersects. Okay. I think I just made it worse. So that is what a piecewise function might look like. Let's see another one. Okay, we have 2x plus 3 and negative x plus 1. Both of these are linear functions, so they're both going to have just a y-intercept and a slope. So plain old lines, we know how to graph those. And it looks like negative 1 is kind of our boundary point. So I'm going to go through and make a mark at negative 1. And that's just a reminder for myself that this is where we're going to switch from one rule to the other. Everything to the left, by the way, I should have said earlier, these functions will always be in order from left to right based on your x values. Okay? So everything over here to the left of that boundary line is going to follow that function rule of 2x plus 3. And then everything to the right of that boundary line will follow the function rule of negative x plus 1. All right, let's get graphing. Let's see, first off, 2x plus 3. Well, it's got a y-intercept of 3. Slope is 2. So my y-intercept is going to be 3, and the slope would be up 2 over 1, up 2 over 1. But keep in mind, we only want this graphed in the yellow region over here. So when I make these marks, it's just going to kind of be for reference. And I'm not going to connect the lines until I get into this region over here. All right, so my y-intercept is 3. Slope is up 2 over 1. I don't really care about anything in this green area, so I'm going to go backwards, down to backwards 1 to get a point there. Repeat that process to get a few more points. So my graph is going to look like that. And according to my function, there is no underline here, so that means it does not get filled in. Empty circle. And I'm going to go ahead and erase that y-intercept just so I don't get confused later on. There we go. All right, next one. We have negative x plus 1. So y-intercept is 1, slope is negative 1, down 1 over 1. So my y-intercept will be at positive 1. And my slope is down 1 over 1, down 1 over 1, down 1 over 1. And I want to continue this in both directions up until I hit the boundary, which is right here. So this line will go forever that way, and I'll put an arrow, and then it will stop at the boundary. There we go. And we have to figure out what type of dot to use right there. Well, it's got the underline, so it gets to be a filled-in dot. Fun. So that's it. All right, last one. This one's got 3, and you thought it couldn't get any more fun. So here we've got 3 different functions, which means there's going to be 3 different kind of zones. I'll color code this again. We'll go yellow, green, we'll call the new one blue. The borderline x values, when I switch from one function to the next, we're going to have a borderline at -2. So right here. We'll have another one at +1. Right there. So -2 and +1. So -2, that's when we're going to make a switch. And then at +1. Ooh. All right, I just had a strange little hiccup with my software. So all that I've done is I took these values and just kind of put them in as my borderlines. So -2 and +1 for the x's. Okay. So anything to the left of -2 is going to follow the yellow function rule. Anything between -2 and +1 will follow the green rule. So this little section here will be a green function. And then anything to the right, or bigger than +1, will follow the blue function rule. All right, so the yellow one, -1/2 x minus 2. That's just a linear function. Y-intercept is -2. Slope is -1/2. So our y-intercept would be -2, and our slope is down 1 over 2, -1/2. Obviously, I don't really care about any of these points because this is the yellow function, so I only want the points over here. So graphing the y-intercept isn't really going to do me much good. Going down 1 over 2 in this direction certainly won't benefit me because, again, I only want the yellow region. So I'm going to have to go backwards. I'll go up 1, backwards 2. Up 1, backwards 2. So now I can get additional points going this way. So now if I did that, these are going to be the points that I come up with. And you can see I'm kind of throwing them nice and faint on there. So I'll graph those with a straight line. And this has an underline, meaning it's equal to, so I get to throw in a filled in circle. There we go. Next step, we have f of x equals 1 between the x values of -2 and +1. So between these two values, my y value, or my y function will just be 1, and that's a constant flat line. And it looks like we're going to have an empty circle at the -2 and an empty circle on the +1. So empty circle there, empty circle there. All right, and then the next one is going to be x minus 2 squared minus 2. So that's going to be a parabola that got shifted to the right and down. So this vertex would be, at +2, comma, -2. So we're going to have a vertex at +2, -2. It's right there. Wrong color. +2, -2. And since it's a quadratic and it hasn't been stretched at all, we would know if it was, if there's a coefficient. It follows that 1, 3, 5 pattern. So I can go up 1 over 1, up 3 over 1, up 5 over 1 to get some additional points here. So up 1 over 1, up 3 over 1, and I'm going to run out of graph. That's okay. So I've got these points here. But I want to make sure that my graph goes all the way until the boundary, and clearly there's a gap here. So I'll need to get this little upswing portion of the parabola as well. So that'll be right there. I know it's going to have a filled in dot because we have the or equals portion. So there we have it. As ugly as it may be, there's our piecewise function. You know the drill, folks. If there's any questions, let me know. As always, good luck, have fun, be safe, roll tide.